All right. So, how many users does it take to break an app? We're not, one. Usually the answer is just one. But sometimes it's more than one, and that's really what we're going to talk about: is how do you pretend to be more than one, and what sort of things are you going to find by being more than one? So, what is load testing? Load testing generally refers to the practice of modeling the expected usage of a software program by simulating multiple users accessing the program concurrently. So imagine I'm a user, I'm going about my daily business, and there's another user also going about their daily business. They both interact with the application at the same time, and they get some result that was unfortunate that did not occur when only one of them was using the app at the same time. Those are the sorts of things that we are going to try and ferret out by using load testing. So we have unit tests for that. This is a low resolution GIF, but it demonstrates the problem pretty well. So each window opens on its own, unit test passing. But when you build the house, the windows don't open, because no one did any integration testing. So unit tests are not the end-all, be-all of how we test software, so that we can avoid that. I think most people in the room can probably think of times when their software's unit tests passed, or they're conceptually, I wrote a test in isolation and everything worked, and then other people's stuff came along and nothing worked. Users don't really like that very much. This presentation is geared mostly towards people who either today currently do this or in the future are hoping to do this, which is your customers interact with your applications over a network of some kind, excluding RDP. So we're not talking about trying to load test RDP. That's not our implementation. It's not your implementation. It's Microsoft's implementation. Someone else has probably done load testing for RDP, but it's not us. Network separated tiers in your applications make this super easy. It's a lot harder when you don't have that clear division anywhere in your architecture to actually decide, like, this is where I can load test my application. So if you have web services, this is inherently baked right in. If you use XF Server Plus or something like that, that's a network layer. You can load test at that level, so that's an option. Cloud-based load testing services really like HTTPS. Some of them will do WCF as well, and SOAP and WSDL type stuff and custom protocols, and let you do whatever you want. But at a start, it's a lot easier if you are HTTPS and like RESTful web service type environments. WCF, it's not really a primary target, but it's still very doable at various cloud hosting based setups or on-site kinds of setups. It's, you can write your own pretty easily. If you have a fat client desktop, it is possible still to do load testing, but that's not really what I'm going to talk about, although some of the principles still apply to you, and I'll call them out a little bit as we go through. So now that I've got awesome load tests and integration tests and both windows open, I don't need unit tests anymore, right? No, you still need unit tests. Please keep your unit tests. They're important. They tell you that things work, the little things work, and when they break, they keep the scope really nice and constrained, so you can say, like, that's what broke, rather than the whole system broke, and now I need to dive in and figure out more specifically. So they save you time when things break, having unit tests. You still need actual integration tests, and you probably still need UI tests. So this is not a replacement for any of the testing that you guys are already doing today. This is an in addition to the kinds of testing that you're doing to improve your customers' experience. So don't stop doing any of the things that you're doing today. And if you're not doing any of these things today, please start doing some of these things today or maybe tomorrow. PSG is around for that. They can help. I have a low volume API. Why do I care about load testing? Even if you only have 2 users, I have heard in the past at customer sites, they both hit the web service at the same time and it broke. Like, it happens once a month and they have no idea why their application fails and corrupts a ton of their data, but it happens once a month. and it is really, really, really angering the customer. So very low volume API, you can still run into concurrency problems with two people. You can still run into concurrency problems with one person if they have two browsers open or two copies of your app open, or if they just like click the button and your app doesn't respond and then they click it again and it fires off another response. That's like two requests happening at the same time. So this still matters to you even if you have really small customer sites and you don't experience a whole bunch of concurrency type stuff. And the reason why we're spending time on writing these is because they are impossible to debug in production. Like, you will never, ever, ever figure out the cause of this if all you have is production. Like, the diagnostic steps for how you solve these things when they fail in production is to create load tests. Because, like, that's the only, you cannot diagnose them in the field. Another really nice side effect is if you write good load tests, they usually double as a really high quality integration test. So they're not going to cover your entire application from a percent of your code hit perspective, but the percentage that they do hit is usually very high quality because you are not using hard-coded data validation. So if you're trying to hit your entire data surface for some little section of an API, as you're thinking about what you're doing with that data, you're going to have to be thinking about it in terms of the whole data set as opposed to customer A, right? Because you're going to go hit like a whole bunch of stuff at the same time and you want to be able to validate back that it actually worked. So typically you end up hitting some big list type function that gives you back a whole bunch of stuff, and then you hit all of those parts at the same time. And the validation that you do is based off of the original list that you got. So it's programmatic. You're not deciding like customer A got increased by $30 in their account balance when I ran this test. You're trying to say like the whole set behaved appropriately simultaneously. So I have an example load test and I have source for it, and it happens to be a Harmony Core web service. But this thing demonstrates account balance transfer. So it picks two random account records. It transfers a random percentage of the current balance from one account to another. The account balance is never allowed to go below 0, and it repeats. So in my case, I make this thing run about 1 million times on 8 threads simultaneously. So that's like 8 people are doing this operation at the same time. And so it runs for 8 million of these account transfers, and then it reads all of the account records, adds all the balances together, and says, no one lost or gained any money, because money cannot come out of nowhere in an account transfer sort of scenario. So I'm doing all of these transfers simultaneously, possibly hitting the same accounts on 2 requests at the same time, and none of them can lose or gain any money. What can go wrong? A lot can go wrong. Optimistic concurrency could result in account balances below 0. So if you're not watching carefully, you're not looking at those GRFAs, or you're not using Harmony Core to have it look at those GRFAs for you, you might store the value that you think should be in this account, but someone else already stored it out from under you. They transferred that money away from you. And so your validation needs to deal with the fact that you need to check to make sure you're still above 0 after your transfer is complete, and it needs to be consistent with the whole system. Locks are probably how you guys manage that today. So just regular pessimistic locking. I lock the record, no one can steal balance from me, and as long as I have locked both accounts, I can take money from one and put it into the other, and then I unlock them both and the data is good. If you only lock one record at a time, you can end up with phantom balance changes. So there's some weird concurrency issues that you can get, and phantom data is one of them. So I read record 1, and I lock it for a moment, and I take some balance out of it, and I store it with that balance removed, and then I load another record, and I have locked it, and I add the balance to it, that money essentially, for a moment, in the system, didn't exist. The system actually had less the money that was in transfer for that split second between this record and that record. So someone who came in could fail to transact off of that because the money was essentially in flight. So your transactions essentially become less repeatable. The behaviors that you will get out of running the same requests becomes less likely to give you the same order of operations because there's an opportunity for values to change out from under you, which is why you guys probably would have locked both records simultaneously and not unlocked them until you were done with the whole operation. So that's how you guys deal with these problems today. One thing that is especially odd is, and this does deal with those phantom balance changes, if I go to calculate at any given time, while transfers are ongoing, what the total balance is for the system, I cannot do it without locking the entire world. Because I start reading it at account 1, and I head towards account 10,000, and the transfers happen behind me, like they move money to behind me, and I don't account for that, and by the time I get to the bottom of the file, I have not counted the amount of money that was available in the system because it moved to behind where I was reading. So things that I had already read changed from out from under me because I didn't lock them. So in relational databases, there are various guarantees that you can ask for, and there's various performance penalties that you receive for asking those questions. But that particular one would be covered by what's called snapshot isolation. But that's not something that you have available to you currently. So, dangerous code. Things that can be in your code that can cause some of these problems that aren't just the ISAM files and the behaviors. If you have global state and you are changing it as part of requests and responses, that's dangerous, as long as that state is being shared amongst multiple requests. It's okay to have global state in a multi-threaded environment, but if you do have global state, it needs to be managed. So you need locks to manage it, or don't change it at runtime. Like if it gets set up front during initialization and then it never changes for the life of your program, it's okay to have globals and statics and comments. It's the fact that you update them during a transaction that's dangerous. So if you avoid that, they're okay. Or if you wrap them in assembly load context or a app domain, then they would also be safe. The next thing that's dangerous is classes that wrap an ISAM channel are inherently just a smidge dangerous, because I've frequently seen these problems occur for people who have written their own wrappers around ISAM channels. So if you close a channel in the destructor, so that's the tilde class name method that exists inside of a class. So if you have a close statement in there, when you move to .NET, or if you run in .NET, or if you're already in .NET, you don't know when that's going to run. It'll run when it feels like running, not when you thought it was going to run. So if you are using Access Server, this is especially unhealthy for your application. So don't do that. Instead of closing a channel inside of a finalizer, you can have a dispose method. You can implement iDisposable. We have this thing called a disposable data statement. So you put the word disposable in front of data, and essentially when that declaration goes out of scope, we call dispose for you. Regardless of whether there were exceptions thrown or whatever happened, your dispose will get called. And it will get called as you're leaving the scope of that variable. So you know exactly when that closed channel is going to be run. So knowing when things are going to happen is a lot safer. Explicit close or dispose that doesn't zero the channel variable. So if you've got that private member that's your channel number and you call close on it and you don't set it to 0, someone else could call close again. And someone might have allocated that channel in the time in between the first time you closed it and the second time you closed it. And now you're closing someone else's channel. So in Synergy, single-threaded environment, totally safe for you to call close 5, close 5, close 5, close 5. We will not complain at you. In a multi-threaded environment, channel 5 got reallocated between the first time you said close 5 and the second time you closed 5. So totally different behavior, breaks your application in the field. You have no idea why it happened, but now you know you can look out for that. Purge and close are the same thing. This was a new one on me very recently, diagnosing a problem at a customer site. They had a close followed by a purge, and it did nothing, literally. It had no operational anything, and in fact, when their application was working correctly, the second call, the purge call, did nothing because the channel wasn't open. But when they had 2 people using the app at the same time, once a month, they got horrible data corruption, and it was really impossible to hunt down. And it took a lot of effort and some very angry customers in order to get there. So yeah, watch out for anything you do with an ISAM channel number and manage those closely. So I have a demo that is using HttpClient in .NET. This would look just about the same if you wrote it in C#, but I happen to have written it in Synergy.NET. So this is my Harmony Core web service, and it's a super duper cut down one as an example. You'll notice the project structure is different because there's almost nothing in it, but it's good as an example. And also as another example, I'm demonstrating that we have a bug in the product because live demos are great for that, but now it's working. So good news for me. All right. So I have in my web service, yes, that one. There it is. So this is hand-coded, so it's not generated. It's running essentially logic for all intents and purposes. We receive the request out from OData, and we go grab the source account and the target account and the amount of money that we want to transfer between accounts. We find the various accounts, and then we enter this do forever loop that basically tries to reprocess the request until it doesn't get a concurrency failure. So it makes whatever the changes are, validates that the source balance has not gone below 0, and then it does a save changes. If we make it out of save changes, everything worked great, it was persisted, return OK, we're done. Otherwise, if the balance would have gone below 0, we have an HTTP return code for unprocessable entity. So that's a HTTP 430 or something like that. And if DB context save changes fails for any reason, we get this DB update concurrency exception. And then we basically just retry. So this is the simplest possible way to deal with a concurrency failure, because I'm just saying, like, whatever caused this failure, I don't really care. I'm just going to try again. So I do. And it goes back around because of the do forever, tries it again. Hopefully it's successful the second time. Over in our actual tester, so this is using HttpClient, we are building up some JSON and serializing that JSON. I could have built this as a string, but it gets hard to manage open quotes and close quotes if you do things manually, so using APIs can be really nice. I specify that it is application/JSON, which is very important actually, because nothing will listen to me if I don't specify the encoding as JSON. And then I post it to our OData web service with this accounts transfer URL here. And it goes off and it sends whatever data that I've constructed. So this is just a helper function, takes the account ID, target ID, and the amount that I want to move. And it does it and returns a status code. Ensures that as long as it's not unprocessable entity, which is the account would have gone below 0, If you get any other error code besides that, it should throw and fail the test. So transfer random says, how many times do I want to do this and how many accounts were there? My data set is really simple. I don't actually need to keep a list of accounts around because I know that the accounts exist from account number 1 to account number of accounts. Like there's no gaps in my data set because I generate my data set every time I start. I know that it's going to look that way. In your guys' case, if you were trying to write this, you'd probably keep around a list of accounts and you'd pick from that list rather than just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's how I've written this. So it will use a random number generator, this random here. And then it goes through and for the number of times that I've asked it to iterate, it will attempt to transfer $12.50 out of an account. I could put rand there as well, and it would be a random amount that I was transferring, but I put 12.5. So once it's finished all of that, it just prints out, hey, I finished transfers. So what you just saw is one thread, one client, asking like a million times to transfer money around. But it's still just one person. It's just pretending to be a very, very active one person. So the load test portion of this comes in down here. So I've picked that I want to represent basically 8 people because that's how many logical CPU cores I happen to have. And if I pick a larger number than that, it doesn't really act as a very fast version of a large number of that. Only so many requests can go out at the same time. So I picked 8, and I add to a list of tasks, which is a .NET representation for a unit of threaded work. I run my thing, and I just keep track of the task. I'm not awaiting it, so it's not happening serially. These will all get fired off in parallel, and they'll run separately of each other. And then I ask .NET to wait until all of the worker tasks are done. So I hand it an array of tasks, and it just waits for all of the tasks to be finished first. And once they're all finished, I go ask for the full account list with all of their balances back from the web service, and then I loop through what has been returned to me, and I calculate all of the maximum balances together and say, like, no, I did not gain or lose any money. I still have the initial starting balances because I shouldn't gain or lose any money. So this is a version of it that I actually ran earlier this morning. I should be able to run it again. And it just starts all of those transfers, and it'll run for a very long time, actually, unless I've broken something, because it's a live demo. I think IIS recycled my process out from under me, and I set a very, very short timeout on my load tester, so it fails that way when it's not spun up yet, because now it is working. So this is a application performance monitoring tool. So it is running on my IIS server, and as requests come in, it sends information about those requests back out to the cloud to report on basically performance metrics and how well the health of my server is doing. Like, there's alerts for, hey, your CPU is running at 99%. You probably need to know about that, because that's not how servers are supposed to be running. Not a good sign. But it also will break down requested actions and what code goes into those requested actions. So while this thing has been running, it's collecting information about what's running and any exceptions that are happening and where this performance is actually going. And we can see somewhere around here. There, I zoomed in. These are basically the exceptions that happened as we were running. So these are not uncaught exceptions. They are keeping track of all of the exceptions that have happened, and they will tell me what they are and where they came from. So if I go to one of them, come on. So it'll tell me where this exception came from. And in my case, it's happening inside of the entity framework provider. And essentially, it's translating a record not same exception from ISAM. Basically, the GRFA didn't match into a entity framework DB update concurrency exception that gets caught later on. And that's that do forever loop that you guys were seeing. So there's a lot of interesting stuff in here, but I have actual slides about application performance monitoring tools. This one happens to be Stackify, and I only chose it because it was really easy. It's got a lot of features, but there's a bunch of competitors, and this was just the easiest one for me to get up and running right away. So you'll notice that the way that I designed that load test, it's set up to not collide. So when they do try and transfer out of an account, two transfers try and transfer into or out of an account simultaneously, they fail gracefully and retry appropriately. What you don't want to have happen is you don't want to create basically a script that's getting followed where if one of your clients gets there too soon, it breaks the rest of your script. Right? You don't want to rely on the current state of one of these things not getting modified by one of the other clients that's running. So I have no dependencies on that whole accounts list other than that they have to have more than $0 in their balance, and that's it. I don't have any dependencies. When I'm done, I didn't need any dependencies in order to decide what the answer was supposed to be. In my case, it was very, very easy. Yours will obviously be harder, but in my case, I was just looking to see, do the balances still add up to what they should have added up to? So one of the ways to do that in a real world sort of environment is you get all the items in a list, you make a reversible change to all of the items in your list, and then you undo the reversible change to all of the items in the list. So now you know what the items should look like because you have the original state of those items, and you can validate that your code, in fact, did a thing, you resulted in a thing happening, and then you undid that thing, and it resulted in it looking like nothing happened, or at least in the places where it's not supposed to look like something happened. If you have code that keeps track of all the transactions that happened to a user, obviously that would contain the transaction that you just performed, but the account balance or the number of items that were there or the notes field is now back to the way it was before you started your load test. So in that way, you can test hitting all of your accounts at the same time, undoing them, and then you have a valid set of data to actually validate against. The other option, besides just building your tests to not collide, is to build a test coordinator of some kind. So one of the ways to do that is in memory. You can use something like System Collections Generic Concurrent. So that's a concurrency safe collection. It's like a dictionary usually, where you can add and remove things without stepping on yourself and without having to lock yourself out of the entire collection. So you can put whatever information you need into one of these concurrency safe collections and then act on that appropriately throughout all of your request agents, through the tasks that you're running. But the coordinator does have to be concurrency safe. Internally, we have gone one step further than this for some of our ISAM tests. We actually use ISAM for our coordination in some of the load tests that we do for ISAM, interestingly enough. Because you can lock records, you can essentially use them as a multi-process concurrent dictionary. So you write whatever records you want to have show up to your other your worker processes, and you lock and unlock as appropriate when you are allowed to or not allowed to update those values. Many of you may have seen that Visual Studio offers load testing features and functionality. Don't use it. It's dead now. They're not being really noisy about its deadness, which is odd. So I actually went to go write a demo and slides to tell you all how to use Visual Studio load testing features, and a quick Googling with Bing resulted in a blog post from one of the PMs talking about how it was dead, and they would be removing it from the product after 2019, and they were dropping support for it in Azure Load Test as of 2020, so don't use it.
Is there a competing product? Or?
There are so many competing products. That's why they dropped it. I will mention several of them right here. So Micro Focus has Load Runner, SmartBear has Load Ninja, there's BlazeMeter, which is one of the many cloud hosting providers for JMeter, and you can use any of them. There's a lot of them. Just writing C# or Synergy code to do the same task, though, as long as you're not trying to simulate 100,000 concurrent users, like, you can usually get away with just writing HttpClient stuff. But if you really need to hit a service really hard, you need to use cloud load testing, because you're not going to be able to hit as hard as they can hit. If you are doing cloud load testing, your service needs to be publicly available. They're in the cloud. They're outside your network. So they can't get to your locally hosted whatever. It has to be a public endpoint in order for the cloud hosting providers to actually hit it for you. So if you have internal stuff, you can run JMeter yourself, or Gatling, or HttpClient on multiple machines simultaneously. But if you need to amplify that, like, I need to hit harder than just one machine can hit, you're going to have to get a little bit creative about where you run your load test clients from, if it's not publicly available. Do I really want to know? You do want to know. So your users are going to know, one way or another, because bad things are going to happen. Unresponsive apps really make users unhappy. And the worst part about their unhappiness is frequently they don't tell you about it until they're really unhappy. Like, they ignore it for a really long time, and then they explode like a poorly timed bomb of incredibly angry user who is just like, your app is slow constantly whenever I use it between the hours of 9 a.m. and 10 a.m. They're just fed up with you. Whatever. So yes, you want to know, you want to test, you want to do something so that either you know your application performs really well, which would be great, or it mostly performs really well, and I'm going to keep track of it in deployed environments so that I know when it's not performing really well in a real environment, and I can say, like, why is it not performing well for users between the hours of 9 a.m. and 10 a.m. So what do I do about it? If you're writing traditional Synergy code, there is a profiler. So it works with DBRs, it works with Exoserver Plus, and it works with traditional Bridge, which is the traditional portion of Harmony Core. You can call developer support. They know how to do it. If the documentation, if you look at it and it looks like it's written in Greek to you, and you're like, I don't know what to do with this, and it's hard, it's spitting numbers at me and I don't know what they mean and I don't know how to use it, developer support can help you decode your performance traces that happen from traditional Synergy. So call them. .NET has a profiler built into Visual Studio. It's pretty good. It tells you a lot of stuff. The traces that you receive for Synergy will frequently have a lot of dollars in them. That's just like name encoding, and you just sort of ignore the parts of the stack trace that look meaningless and look for the English-looking words or the words that look like, whatever your variables are or whatever your method names are. Generally, they're actually pretty easy to pick out, but don't be too freaked out if you see weird characters in the performance stack traces that you get there. In addition to the profilers that are built into Visual Studio, I am a huge fan of JetBrains performance analysis tools. So .profile is excellent. It is really, really good. The thing that differentiates it from Visual Studio is the querying and drilling down and sort of they get you to what went wrong a lot faster than Visual Studio Profiler gets you to what went wrong. And same deal with .memory. It's a lot faster to figure out, like, why is my application generating 40 gigabytes of garbage every second? And when I say garbage, I literally mean like garbage collected data. Like, the more garbage that you produce, the slower your application is going to run. So identifying sources of unnecessary garbage is a really good way to make your application go faster. So I like JetBrains a lot. They will feature again in the future. So you used the profiling tools, you made it faster, you ran your load test, again, made it faster. How do you keep it that way? So your load tests should be run from your DevOps pipeline. If you don't have a DevOps pipeline, work towards having a DevOps pipeline, because it can make your life a lot better to have your tests run automatically every time you do a build. If for no other reason, then you can say, like, so-and-so just checked in this thing, and there was a performance regression. So I can say, your commit made the software run unacceptably slower, and we can go fix it, rather than a user saying, like, the new version is slower when I do blah. You'll know this feature made the product go slower. And if you don't care about that, that's fine, but at least you know that that happened before the users know that that happened. The closer to production you run your load tests, the more accurate they're going to be. So if you run your load tests on your developer box, it's not going to give you the same sticking points as running it on some 128 core, $100,000 like mega server that has gigantic hard drive arrays attached to it and huge network pipes. Like, you're just not going to fail the same way or go slow the same way. It doesn't behave the same way. So the closer to production you can get, the more accurate your results are going to be. So yeah, similar hardware is helpful. JetBrains has unit test integration. So along with their profiling tools, they actually offer coded ways that you can make performance requirements part of your unit tests. So as those get run, they can say, you're not allowed to allocate more than this amount of memory as part of running this test. So you can actually have it at that fine level of unit tests. You can say, you can't allocate this much memory. If you check something in that allocates too much memory, I will know about it because the unit test will fail. They do the same thing for CPU, and it makes it a lot easier. It moves discovery of the failure a lot sooner. And the sooner you find out about something going wrong, the less likely it is for someone else to find out what went wrong, which is good for you, I think. So it's great. What else can I do? Application performance monitoring tools are how you do this stuff in a production environment. So the little bit of UI that I showed you guys, that was Stackify, but there's also Splunk, SolarWinds APM, and New Relic. Those are the main competitors in this space. And they all offer pretty similar feature sets. So they have customizable alerts. So if an important request is taking longer than a certain threshold, they will generate email alerts or text messages or whatever it is that's supposed to go out. In addition to the basic things that they offer, which is they collect performance traces for everything that's going on, you can also do custom logging. And we actually do a little bit of this stuff for you already inside Harmony Core for things like Synergy IO ops. So once you have finished running one of these big EF queries, like the one that Steve showed where it was doing this massive join and returning a bunch of data, we actually keep track of the number of on-disk IO ops that occurred as part of satisfying that request. So we actually report that out to the operating system, and the operating system dutifully reports it out to your APM tool, and they can record it if they want. So you can say, people hitting this endpoint should never cause more than 500,000 IO ops to occur as part of a single request. So you can make those sorts of thresholds, and you can generate alerts when things leave those thresholds, or if things are trending higher in those thresholds, you know about it, and you can go figure out why are things trending higher in production environments. So it doesn't even necessarily need to be tied to a code event. You might have deployed this code a month ago and you haven't touched it, and all of a sudden the amount of time it takes to satisfy a request is getting worse and worse and worse and worse and worse, and I haven't changed the code, the server isn't different, what's going on? So APM tools can tell you the shape of the activity that's going on, and they can tell you in production, why is this happening to me right now? It might be that users are using your application differently. Someone sent out an email with tips and tricks for how to use your application better, and by the way, those tips and tricks are very expensive tips and tricks. So it's helpful to know what is actually happening in that sort of opaque production environment that you normally have no window into. And with that, who has the first question?
How do you lock multiple records in an ISAM file? Only with multiple channels?
I use manual locks to do it, generally speaking.
How do you do a manual lock?
Q_manual lock, I think. So lock : Q_manual lock. Okay. So you have to unlock those. You are responsible for managing that. And you would never ever want to keep around a channel that you're using manual locks on if you have any fear whatsoever of forgetting what record was locked. You want to manage that really closely.
What's it required to do an unlock?
So you can either do unlock on channel, and that unlocks the current cursor position on the channel. If you want to unlock some other record, you have to position to it in order to use that unlock channel form.
You record the RFA when you do the original lock?
You should always gather the RFAs if you're using manual locks. The other way is you can nuke all of the manual locks that you have on a channel in one xcall. It's like xcall free, I think. If you say free channel number, it'll unlock all of the locks that you have on a particular channel.
If you've manually locked a bunch of records and you lose connectivity, do those...
They unlock.
They do?
Yes, they do. Access server is responsible for managing those.
Okay, so the server in that case...
Yes. There is some change probably coming there in a future version to do with portability of those locks across connections. So Access server is now resilient to connections going up and down. But if you are operating in a clustered type environment in VMS, this machine is not that machine. So it doesn't have the locks from this to that. So there's some optimism that can occur there if everyone is coordinated. That can make that reconnect experience happen the way you want it to, as opposed to the way you fear it will. All right.